All right, so last class before vacation doesn't mean that you can all forget about this, okay? This is a very important class.
No, all the lectures are going to stay up online with vacation.
You can, everything is going to be there until the end of semester. I know. People who miss it, they really miss something, yeah. So we just stopped right here in last class, that is process of determining amount of a reactant or product from another reactant or product is called stoichiometry, and we are going to see how we do this. So let's consider the reaction we have been seeing so far. This was the reaction we looked at in last class to understand what do those numerical coefficients mean. And we said that the numerical coefficients means the number of moles in the reaction, right? Or 1 mole of propane reacts with 5 moles of oxygen, producing 3 moles of carbon dioxide and 4 moles of water. So those, yes?
Just a quick question. Does that mean that there's 10 moles of oxygen, this oxygen dioxide?
When you count the number of atoms of oxygen, there are 10 on the left side.
Does that mean 10 moles?
No. Moles, only the numerical coefficient in front of the formula. They represents the number of moles. Okay? The subscripts represents the number of atoms in the formula. So, when we do this conversions, that is, if you know, let's say for example, you have 5 moles of oxygen, and you want to know how many moles of carbon dioxide will be produced. Well, you don't have that information. Let's imagine that. So how would you find that out? It's called, what we need is called mole ratio. That's what we are going to learn now. So a mole ratio is used to relate the number of moles of one reactant or product to another. It's very easy. Mole ratios are obtained from the chemical, the balanced chemical equation. And say for example, if you want to know the mole ratio of oxygen to propane, the mole ratio is 5:1 or 5 moles of oxygen per 1 mole of propane. Where do we get those numbers from? Watch the equation and the ratio one more time to understand where do they come from. Just look at that equation, the balanced equation. Okay? And all we are doing here is what is the mole ratio between oxygen and propane? And look at the ratio given there. 5 moles of oxygen per 1 mole of C3H8. Where do we get those numbers, 5 and 1 from?
You're going to take the mass.
You don't need anything, guys. The answer is right there. Look at the balanced equation. What is the number in front of propane?
5 moles to 1 mole.
So when there is nothing, I said there is an invisible 1 there. Right? When there is no number written, we would assume it's a 1. So we just said that 1 mole of propane and 5 moles of oxygen. That's what they are reacting. So 5 moles of oxygen needs 1 mole of propane. That is the mole ratio between oxygen and propane. Those numbers, the numerical coefficients we learned, we said they represents the number of moles. So what is the mole ratio? The ratio of those two numbers. If it is asking oxygen and propane, then you look at the number in front of oxygen and look at the number in front of propane. So 5:1. If I am asking you the mole ratio between carbon dioxide and water, what would you say? What is the balanced equation says? How many moles of carbon dioxide and how many moles of water? Well, so the same thing. Thomas said 4:3 and Senia said 3:4. They are not one and the same. So how do we decide which is the correct mole ratio?
Well, on the other one, it's 5:1 and oxygen is 5, so I was thinking along
No, that is not the way you do it. You should take the clue from how the question is worded. Okay? So, if, let me just show you that. Let's say this question, this was asking mole ratio of oxygen to propane. Correct? Oxygen to propane. So you took the number of oxygen first to propane. This is, the ratios are read as 5:1 or 5:1, right? So you should take clue from how the question is worded. If you are looking for oxygen to propane, then the number of oxygen comes first and then comes the number of propane. So my question here is carbon dioxide to water. How would you say that ratio? 3:4, or 3 moles of carbon dioxide per 4 moles of water. Okay? So that is how you represent the ratio, comes from which one is worded first in the question, or how the ratio is asked in the question. Now, the small ratio of oxygen to propane, which we just saw as 5 moles of oxygen per 1 mole of propane, this would allow us to calculate the amount of oxygen that will react with any amount of propane. If we know that 1 mole of propane needs 5 mole of oxygen, then we also know that 10 moles of propane will need how many moles of oxygen? 1 mole needs 5, 10 mole will need, why 2? I said this is 1 to 5. Now if I increase this number to 10, what will happen to the 5? Which will also increase by a factor of 10, right? So 5 times 10, 50. Isn't that the same ratio, guys? If 1 mole needs 5, then 10 mole needs 50. 100 moles will need 500. We see that table in last class, right? We saw already that table. So that is all it's saying. So if you know this ratio, that is 1 to 5, then it doesn't matter if I ask you to calculate the number of moles of oxygen you will require for any amount of propane, you can calculate that. Say for example, here I have 0.4 moles of propane. I want to know how many moles of oxygen I need for that reaction. How do we figure that out? Using the mole ratio in a dimensional analysis. So this is what I am given, 0.40 moles of propane, and I am looking for how many moles of oxygen I will require. So that means I should use the mole ratio between propane and oxygen. How would I use it? What is it I am looking for? I am looking for moles of oxygen. Put that in the numerator. What moles I am given? Moles of propane. Put that in the denominator. And then you can see clearly the moles of propane and moles of propane will cancel, and you will get the number of moles of oxygen. So if you have the balanced equation, that's all you need, because balanced equation gives you the mole ratio, and then you can calculate from any amount, any amount. That is what is stoichiometry is all about. Let's do more practice. So here is another reaction. Benzene C6H6 burns in air according to the following equation. So here is the balanced equation. 2 moles of benzene needs 15 moles of oxygen, and it will produce 12 moles of carbon dioxide and 6 moles of water. That is the equation given to us. Now we have to answer some questions here. First question is, what is the mole ratio of O2 to C6H6? How would we write that mole ratio? O2 is O2 to C6H6. That's what it is asking. So how many moles of O2 and how many moles of benzene? 15 to 2. Right? Or if you want to write that as a fraction, 15 moles of O2 per 2 moles of C6H6. Note that the ratios can be expressed as a fraction also. Okay, mathematically they are one and the same, a ratio and a fraction. Okay, now how many moles of oxygen are required to react with each mole of C6H6? Yes, how do we get that? Or in other words, what is your thought process? It's asking how many moles of O2 are required to react with each mole of C6H6. Or in other words, it's saying you have only 1 mole of C6H6, then how many moles of O2 you need?
15 over 2 is the same as 7.5.
Yes, or you can look at the balanced equation. 2 moles of benzene needs 15 moles of O2. Now I'm saying you have only 1 mole of benzene. So you have only half the amount of benzene. So you need only half the amount of oxygen. Right? So half of 15.15 is 7.5. That is one way of thinking, because it was, the relationship was so easy, taking the half. But how would you otherwise write this problem? What is given to you? Each mole of C6H6. So you have 1 mole of C6H6 which is given to you. You need to multiply this by the mole ratio between oxygen and C6H6. What is the mole ratio? 15 to 2, which we already have done in the first question. So 15 moles of O2 per 2 moles of C6H6. So again, in the dimensional analysis, moles of C6H6 and moles of C6H6 can be cancelled. Once again, what would you get as the answer? 7.5 moles of O2. So once you identify the mole ratio, it doesn't matter how many moles you have. You can always multiply that by the mole ratio and you will get your answer. Let's look at this one, then you will get it more clear. So now the question is, how many moles of O2 are required to react with 0.38 mole of C6H6? So all we have is 0.38 mole of C6H6. Once again, which mole ratio we need to use? The mole ratio between oxygen and benzene, because that's what the question is dealing with, right? How many moles of oxygen you need for this many moles of C6H6. So again, we need the mole ratio between oxygen and benzene. How will I use the mole ratio? Which will go on the top, which will go on the bottom? 15 moles of O2 goes on the top and 2 moles of C6H6, oh, C6H5, I wrote it as C6H5, what a stupid thing. And nobody told me. I said 6 but I wrote 5, wow, okay. So we write the mole ratio like that, and once again moles of C6H6 and moles of C6H6 can be cancelled. So do that math. What do we get? How many moles of O2 you need? 0.38 times 15 divided by 2. What do you get? 2.85 moles of O2. So again, just look at this, guys. What are we actually doing? As long as you get the balanced equation, you are good. Because whatever mole ratio you are looking for, that comes from the balanced equation. The numerical coefficients in the balanced equation makes up the mole ratio. Now, the question will be asking like, you will be comparing 2 only at one time. Okay, there won't be a question like how many moles of O2 you need for 2 moles of C6H6 and 12 moles of carbon dioxide, not like that. Always you will be comparing 2 things. Okay, So first, by looking at the balanced equation, find out what is the mole ratio. That is your first goal. Then whatever is given in the problem, say for example here the moles of C6H6 is given. So whatever quantity you are given, multiply that by the mole ratio. When you write the mole ratio, be careful. Whatever is given in the problem, make sure that part in the mole ratio is in the denominator so that you can cancel the units properly. And whatever you are looking for, that is how many moles of O2. So oxygen is what you are looking for. So write that part as the numerator. Yes?
It gets the same answer, but is it okay to do the 7.5 over 1?
That's fine because 15 over 2 is mathematically 7.5. That is why you get the same answer. But why I am showing this way is in rest of the problems also, this is what you will be doing, using the mole ratio. It won't be all the time as easy as 15 over 2.
Right, I was just wondering if
Yeah,
matters.
it doesn't matter.
Over 2.
Yeah, it doesn't matter. Okay, so yes, here is the problem worked out as we have just looked in the previous slide. Now I guess I have more problems on this. So the same equation, but this time we have a different one. That is, what is the mole ratio of carbon dioxide to oxygen? What is the mole ratio? Carbon dioxide to oxygen. That is how it is worded. So 3 to 5, or if you want to write that as a fraction, how would you write it? You will write 3 mole of carbon dioxide over 5 mole of oxygen. Good. So that is the first question. Now the second question is, how many moles of carbon dioxide will be produced when 2.3 mole of O2 reacts? What do I need to do? I need to, what am I given? I am given 2.3 moles of O2, right? So 2.3 mole of O2 is given. I need to multiply this by the mole ratio. Whatever quantity you are given, guys, multiply that by the corresponding mole ratio. That's all you need to do. So how will I multiply? So I am looking for how many moles of carbon dioxide will be produced, right? So I am looking for the number of moles of carbon dioxide. So make sure when you write the mole ratio, mole of carbon dioxide will be in the numerator. So 3 mole of carbon dioxide in the numerator and 5 mole of O2 in the denominator. So again, moles of O2 and moles of O2 will go away, and what will be your answer? 1.38 mole of carbon dioxide will be produced. So it's very easy once you get this. That is, balanced equation gives you the mole ratio. Okay? So whatever amount is given in the problem, multiply that quantity by the correct mole ratio. So take care when you write the mole ratio, which one goes in the top, which one goes in the bottom. And I told you the clue. Whatever quantity is given in the problem, that mole ratio, that part should be in the denominator. Whatever you are looking for should be in the numerator. Oh, they had the answer right there, and which is just exactly on top of what I have written. So here is another reaction. 2 aluminum reacting with 3 chlorine forming 2 aluminum chloride. How many moles of chlorine are required to produce 0.62 mole of aluminum chloride? What are we given? We are given the moles of aluminum chloride. Okay. So this is what I am given, AlCl3, and I need to multiply this by a mole ratio. right? So what is the mole ratio I am using and how would I write it?
2 mole ALC.
What are we considering? What are the two things we are considering? Aluminum chloride and what else is? Read the question, it's right there.
Three's on top, three's on bottom.
We are considering chlorine and aluminum chloride, right? So obviously we are looking for a ratio between that. That is the mole ratio we need to use. And we know that aluminum chloride's numerical coefficient is 2. Chlorine's numerical coefficient is 3. So these are the two numbers I am going to use. How would I use it? Which one on the top? Which one on the bottom? Cl2 on the top because that's what I am looking for. How many moles of Cl2, right? So 3 moles of Cl2 on the top and what am I given? Aluminum chloride. So that one goes in the bottom. So 2 mole of aluminum chloride in the bottom. So again aluminum chloride and aluminum chloride get cancelled away. And how many moles we have? 0.93 moles of Cl2 are required. So did you get this concept? As long as you have the correct balanced equation, you are good. It's just simple multiplication afterwards you have to do. Because the balanced equation tells you the mole coefficients. Okay? So whatever quantity you are given in the problem, multiply that quantity by the correct mole ratio. Identify the correct mole ratio from the balanced equation and just multiply. That's all you need to do. Again they have the, okay. Alright, let's take out the clickers. So here is, you have seen this equation before and the question is asking how many moles of carbon dioxide will be formed when 2.7 mole of propane is burned. So go ahead and do the calculation carefully and then choose the right answer. So read again carefully, what are you given and then what mole ratio are we using. Use it correctly, that's all. I will stop at 3 minutes, okay? That's, I know that it's 10 times the time you need, but that's okay. So make sure you answer before 3 minutes. Everyone has clickers today? Everyone has, right? Okay. Louis, I know you may not be able to answer this, but take your clickers and click so that your attendance is registered. And who knows, you might get lucky. Okay, so how many I have? 19? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. Oh, they're all 19. Okay. How would we do this problem? What are we given? We are given 2.7 mole of C3H8. We need to multiply that by a mole ratio. What is the mole ratio we need to use?
3 moles CO2.
The mole ratio between carbon dioxide and propane, because those are the two things we are asked in the problem, right? So we are looking for carbon dioxide, therefore we will write that quantity on the top, 3 moles of carbon dioxide over 1 mole of C3H8. So what do we get? 8.1? 8.1 mole. All right. Okay, I have, good, 16 of them. Correct answer. I don't know, how do you get 6.676? If you use the mole ratio the wrong way, do you get 0.676? No, you still won't get that. You will get a... Okay. Anyway, I have no idea how the other numbers are. If anyone wants to volunteer how you got the other answer. Okay, not forcing anyone. If you understand the mistake, that is the goal of this exercise. So that's good. All right, now the next one is mass to mass conversion. So mole to mole conversion was just a small part or just was the one step, right? Usually when we do things in the lab, do we have any instrument which we measure number of moles? We don't, but we have analytical balance where we commonly measure the mass of the substances, right? And we work with mass, and again the balanced chemical equation does not tell us a mass relationship, it tells us only a mole relationship. So we need to do the conversion between mass and mole to do a problem typically in the lab. And we all know how to convert between mass and moles. We learned that in chapter 4, right? Okay, so we will be using that again here. Now here is a problem. The chemical reaction is sodium and chlorine reacting and forming sodium chloride, formation of salt. The balanced equation is 2 sodium reacting with 1 chlorine molecule forming 2 moles of sodium chloride. The question is, what mass of chlorine gas is required to react with 9.20 grams of sodium? Note that it is asking what grams of chlorine is required, and the amount of sodium is also given in grams unit, not moles anymore. So you cannot just take the mole ratio and multiply. You cannot, right? Because this is grams, this is not moles. If the question was asking 9.2 moles of sodium, yes, you can multiply that by the mole ratio and you will get moles of chlorine. But here the question is all about mass. So what do we need to do first? We need to convert the 9.20 grams of sodium to moles of sodium, and we all know how to do that, right? How do we convert mass to moles? Using molar mass. What do you do with the molar mass? What do you do with the molar mass? Multiply by the reciprocal or divide by the molar mass. They are one and the same. So that's what is given there. So as it says, for a review, see section 4.2. If anyone is not still sure about the molar mass conversions, it is section 4.2. Spend some time on the break to get chapter 4 under your shoulders. Because without that, this chapter further we move along, it becomes really tough. Okay? Because these calculations you learned in chapter 4 will just come as a part of your problem here. These are bigger problems. So make sure you understand that and you learn that if anyone is still not sure about chapter 4 calculations. Okay, so first point is we need to convert the sodium to number of moles of sodium. So using the molar mass of sodium, we have converted to number of moles. So now instead of saying we have 9.20 grams of sodium, you can say we have 0.4 moles of sodium, right? Because we just converted 9.20 grams to moles and this is what we get. Now, if we know the number of moles of sodium, can we calculate the number of moles of chlorine we need? Yes, we can, because that's what we did in the previous section. If you are given a particular number of moles, can you calculate what is the number of moles of the other thing you need? Right? How do you do that? The number of moles of sodium which is given, multiply that by the mole ratio between chlorine and sodium, because that's what you are looking for, right? Chlorine and sodium, how much chlorine you need. So the balanced equation says 1 mole of chlorine per 2 moles of sodium, so that is the mole ratio, and you end up with the number of moles of chlorine. Is the question asking how many moles of chlorine will be required? No. What is it asking? It's asking how many grams of chlorine is required. So what do you need to do? What is the final step?
Times 0.200.
Just tell me in words. What is the final step? Converting that number of moles of chlorine to grams of chlorine. So right here, so now you have 0.4 moles and you converted, when using the mole ratio you found that you need 0.2 moles of chlorine. The question is asking what mass of chlorine is required to convert that by using the molar mass of chlorine. Not that it is chlorine Cl2 you are converting, therefore use the molar mass of Cl2, not just a Cl from the periodic table. Okay? So when you convert, you will get 14.2 grams. So there you have all the information. So read the question again and just go through what are the steps we did. So the question was asking what mass of chlorine is required, and it was given to you mass of sodium. We know that we do not have any direct relationship between mass. So whenever you see mass, guys, just remember this. We cannot do any calculations or any conversions directly using mass. The moment you see mass is given in the problem, convert that to number of moles using the molar mass of the substance. You can only do the conversions between number of moles. So you started here 9.20 grams, you converted that to moles using the molar mass of sodium. Then using mole ratio between sodium and chlorine, you find out how many moles of chlorine you require. The question was asking what mass of chlorine, so you converted the moles back to grams using molar mass of chlorine. Okay? So it's the same concept from previous section, but except that instead of moles, it's mass now. So you need to do that one extra conversion. So those are the steps again. So if let's say you have grams of one reactant A, using the molar mass of A, calculate to moles of A, then only you can use the mole ratio. Never use the mole ratio directly on mass. Okay? If I see anyone doing that, I don't know what to do. I have to come up with some good punishment methods. Think about it over the break and bring me suggestions. So you can use mole ratios only on moles, not on mass. And then you calculate the moles of B, then using molar mass of B, convert that back to grams. Let's do another example. Oh, so same question, but now this one is different. So same equation, here the question is what mass of NaCl should be produced when 9.20 grams of sodium reacts with 14.2 grams of chlorine. We just calculated this number in the previous section, right? How many grams of chlorine is required? And this is what you got. Now, here the question is asking what mass of sodium chloride will be produced. Before you start doing anything, the question gives more information than you require. That is one way, but that is not the correct way, because in this chemical reaction, yes, there is only one product. So assuming there is a 100% reaction, yes, the mass of the reactants should be equal to the mass of the products. But when you have a reaction with more than one product, and if you are trying to find out just the mass of one product, would adding up work? It will not. So I would not suggest you do that, because that will work only on this problem. Okay? So let's just learn the right way, the method. So here you are given more information than you require. All you need is mass of one reactant. You don't need both. Right? So let's say, let's consider only this one. You can do the same thing with only chlorine also, but let me just pick up the sodium because that is what is given first. So let's assume the question is reading as what mass of NaCl should be produced when 9.20 grams of sodium reacts. Okay? So first step is converting this to number of moles. You already know that. How many moles of sodium we have? 0.4 moles. Yeah, for the sig figs you have to write that way. So 0.400 moles of sodium. That's what we have. Now if you have 0.4 moles of sodium, first step is how many moles of NaCl could be produced. How do we calculate that? We are given this. We are looking for how many moles of this will be produced. So which mole ratio you will consider? The mole ratio between sodium and sodium chloride. What is it? It's 1 to 1. Or in other words, it says 2 moles of sodium will produce 2 moles of sodium chloride. So if you have 0.4 moles of sodium, it will produce how many moles of sodium chloride? 0.4 moles, right? It's 1 to 1. So you will have 0.4 moles of sodium chloride produced. Is the question asking how many moles of sodium chloride will be produced? It's asking how many grams of sodium chloride. So what do you need to do now? Convert the moles to grams using molar mass of NaCl. So what is the molar mass of NaCl? Take your periodic table, calculate it. Na is 22.9, Cl is 35.5.
58.44.
Okay, so 58.44 grams per mole. That is what is the unit, right? So the mole and mole will go away and you get the grams of NaCl. How many grams of NaCl? 23.376. How many sig figs we need? We need only 3. So 23.37, 23.4 grams. As I said, only in this equation it will work because you have only one product. Okay? But if it is an equation like we had seen the previous one, the propane burning, when you have 2 different products, if it's asking mass of water, can you just add the mass of propane and oxygen? No, you won't, because some is for carbon dioxide also. So how do you decide what is the mass of water? You have to go through these steps. Yes?
To double check your answer, could you find out the masses of all the products and add them together, which should be equal mass in the rest of them?
Yes. You can. That will be but too much work though. But yeah, if you want to check, that is one way. Calculate the mass of every product that can be produced and then add up all the reactants, add up all the products, and they should be the same. According to the law of mass of conservation, it should be the same, theoretically. Okay, let's do another problem. So here is an equation given. This is when the hydrogen gas is used as a fuel in shuttle launch. This is what the formation of water. It's an explosive reaction with a lot of heat produced, and that is the heat energy they use for the shuttle launch. So if 1.8 into 10 to the power 8 grams of hydrogen is used in a liftoff during a shuttle launch, then we have to answer a couple of questions. What mass of oxygen gas is consumed? What mass of water vapor is produced? And then, does the mass of water vapor equal the masses of the reactant? If so, then what law describes this observation? We know that part. Our first goal is, the important thing is, how do we calculate number 1 and 2? So the first question is, what mass of oxygen gas is consumed? Are we given any moles in the question?
Yes.
Read that again. It says 1.8 into 10 to the power 8 grams of hydrogen. So what is our first step? Finding the moles of hydrogen, or converting the mass of hydrogen to moles of hydrogen. Okay, let's go ahead and do that. Let me pick up a new screen. So I have 1.8 into 10 to the power, what was it? 8 grams of H2. That's what I have. I need to convert that to moles. What do I need to do? Molar mass of H2. What is the molar mass of H2? 2.016. Okay, what do I do with it? Okay, how do I write it, guys? Come on, this is chapter 4. You should all be giving me answer fast. How do I reuse it? What goes on the top, what goes on the bottom? 1 mole goes on the top and 2.016 grams goes on the bottom, so that the grams and grams can go away. So how many moles of hydrogen you have? Do the calculation, please. What is it? Why everyone has the calculators? What is it, Sean? 8.93? 8.93 into 10 to the power 7, did you say? Okay, so that is the number of moles of H2 I have. Now we can answer the first question. If I have 8.93 into 10 to the power 7 moles of H2, how many moles of oxygen I need? What was our chemical reaction? Reaction was 2H2 plus O2 giving 2H2O, right? Okay, so this is the moles of H2 I have. So how do I find out how many moles of oxygen I need? Multiply this by the ratio. Okay, give me the ratio. What goes on the top, what goes on the bottom? We are looking for the moles of oxygen, so that goes on the top. So 1 mole of oxygen per 2 moles of H2. So now again moles of H2 go away. How many moles of oxygen I need? Do the calculation. It is 8.93 into 10 to the power 7 divided by 2. .47 into 10 to the power 7 moles of O2. Was the question asking how many moles of O2 is consumed? It's asking how many grams of O2 is consumed. So what is the last step? Converting this moles of O2 to grams of O2. What do you need? Molar mass of O2, which is 32. Okay. So multiply this by 32 grams per 1 mole. So how many grams of O2 you require? You will have the answer when you finish that math. So this was our first question. How many grams of O2? 1.43 into 10 to the power 9 grams of O2. So everyone see the steps again. This is what we were given. Just the mass of hydrogen. We cannot do anything with mass. So the first step was converting that to moles of hydrogen using the molar mass. Once we get the moles of hydrogen using the mole ratio from the balanced equation, you can calculate the moles of oxygen. Now the question was asking what mass of oxygen you need, not moles of oxygen. So we converted the moles of oxygen to mass of oxygen using molar mass of oxygen. Now what was the second question? If anyone copied it. We go back and see. Sometimes when I go back, I will lose what I wrote. And did anyone copy the question? Let's hope I won't lose it. Oh, I might lose it. Yes. Second question is, what mass of water vapor is produced? Yeah. So this was our first one we just did. Grams of hydrogen to moles of hydrogen, mole ratio, then back to mass of oxygen. So 1.4, because we had only 2 sig figs, they are using 2 sig figs, we got 1.43, right? So for 2 sig figs we will leave the 3 out. Okay, so next question is, what mass of water is produced? So once again let me write the balanced equation. 2H2 plus O2 giving 2H2O, and we had 1.8 into 10 to the power 8 grams of H2. That's all we started with. So this time the question is, what mass of water will be produced? So once again the first step is the same. We can't do anything with grams, so we are going to convert this to moles of hydrogen. So we know that step, so let's do that one first. So 1 mole per 2.016 grams. So how many moles that was? 8.93 into 10 to the power 7 moles of H2, right? Okay, now the question is, how many grams of water will be produced? So first we need to find out how many moles of water will be produced. Look at the balanced equation. What does it tells you? The ratio between hydrogen and water is 2 to 2 or 1 to 1. So if you have 8.93 into 10 to the power 7 moles of hydrogen, how many moles of water will be produced? 8.93 into 10 to the power 7 moles of water, because it's 1-to-1 ratio, right? So whatever amount of hydrogen you have, the same amount of water will be produced. So we have 8.93 into 10 to the power 7 moles of water. Is the question asking how many moles of water? No, it was asking mass of water. So what do I need to do? Convert this to grams. What is the molar mass of water? 18.016 grams per mole. So, how many grams of water will be produced?
You got 1.6 10 to the power 9.
1.6 into 10 to the power 9 grams of water. That is correct. So this was worked out, whatever we have done. So note that again we had 1.8 into 10 to the power 8 grams of hydrogen. We converted that to moles of hydrogen using molar mass, and then use the mole ratio, 2 moles of water per 2 moles of hydrogen, or in other words it's 1, right? Multiplying by 1, which is the same. Then we convert that to mass of water by multiplying with the molar mass of water. Now the last question was the mass of water vapor. Is that equals the total mass of the reactants? So these were the masses now. 1.8 into 10 to the power 8. Oxygen we calculated as 1.4 into 10 to the power 9. If you add these two numbers, yeah, you will get 1.58, which is very close to 1.6 into 10 to the power 9, right? Well, why notice that these numbers don't get carried away with that 1.6 and 1.4 and 1.8. Look at the exponents. Those are big numbers which you can't imagine. I mean, well, 10 to the power 9 is what? Trillion? Yeah. So you are comparing a trillion grams, so 1.58 or 1.6 doesn't make any difference. The difference is 0.02 grams difference, right? That's all you are seeing right there. So the law of conservation of mass is followed here. Another question, mass to mass conversion. So here, read the question carefully. When aluminum metal is exposed to oxygen gas, a coating of aluminum oxide forms on the surface of the aluminum. The balanced equation for the reaction is given as 4 aluminum reacting with 3 oxygens and forming 2 aluminum oxide. Now, suppose a sheet of pure aluminum gains 0.09 grams of mass when exposed to air. Assume that this gain can be attributed to its reaction with oxygen. Question is worded a little bit different. You need to use your brain here. Okay? The question doesn't say directly what mass of what reactant is given. Read that line again, and what is it coming to your mind? What does it say? What? No. So we have a sheet of aluminum. Okay, we don't know the mass of that. Doesn't matter. So this sheet, we knew the mass before it was reacting. It is not given in the problem. Let's say we measured the mass before the reaction when it was pure aluminum. We let it react with oxygen, and we see that its mass has increased 0.09 grams. So what do we mean by mass is increasing? Or where does that mass increase come from? Who is responsible for it? That is what first you have to identify. Well, it says it is attributed to the reaction with oxygen, right? So, is it the mass of oxygen reacted, or is it, read this first line also. When it is exposed to oxygen, a coating of aluminum oxide forms on the surface of the aluminum. So let's say if you had the aluminum pure sheet 10 grams, after the reaction it is weighing 10.1 gram. Now remember, after the reaction it's not pure aluminum anymore, you have a coating of aluminum oxide outside, right? And the mass has increased 0.1 gram. So what that 0.1 gram is? The aluminum oxide, the coating which is formed on top of aluminum, right? Make sense? So, if it gains 0.09 grams of mass, what does that mean? It is heavier, yes, in the chemical reaction wise. What does that mean? The mass of aluminum oxide formed is 0.09 grams, because otherwise how will the mass of the aluminum sheet will increase? It has to be because an aluminum oxide coating is on top of it, right? Is that clear, guys? Making sense now when you think through it? So, I guess this question, maybe I didn't want to show you this. They did this problem wrong on the PowerPoint. Let me think, what do I need to do? Should I give you another problem and from the book and work with it, or yeah, I will do that. Give me a book, guys. We'll pick up another problem. Because this one, if you see later, I have noticed that they did it completely wrong and I can't edit it. They won't give me the equation editing privileges on their PowerPoint, even when they are wrong. Yeah. So, let me just go to your end of the chapter and pick up a problem and we will just do it. I'll just pull out a blank sheet and I'll do it. And you can read the problem from your book. Mole, mass conversions. That was actually 6.22, this problem. Let us do yes, that is 6.22. How about we do 6.20? Is that fine? When the reddish brown mercury 2 oxide is heated, it decomposes to its elements, liquid mercury, metal and oxygen gas. What is the molar mass of HgO? What is the molar mass of Hg? Well, those are, we know that. When 2 grams of HgO is decomposed to Hg, predict the mass of pure Hg metal produced. That's an easy one, guys. Let's just do this one and without looking at the PowerPoints, because I think
Teachers taught for thousands of years.
I know, But thing is that this is all recorded and it will be put in there, so I didn't want you guys to go through this and get confused why this is different. The problem with this problem, what I found is when they say a coating of aluminum oxide forms on the surface, the mass gain should be because of the aluminum oxide, right? But when later when they do the problem, they attribute they do that as this is the mass of oxygen that reacted. Which is, when you think logically, it is wrong. Because oxygen is the gas, it's not going to stay on the metal sheet and you cannot weigh that, right? If there is a coating on the metal sheet, then the mass is increased means the mass increase has to come from that metal coating, right? That is my point. And I guess, yeah, see. They use that mass for the oxygen. That is where I have a problem with this question. Do you get my problem? Now, why the book is wrong on this one? Because if it is pure aluminum and if it gains the mass, then the mass has to be because of this coating formed. But they say the mass gained is because of the because of oxygen, yes, because it's reacted with oxygen. That sentence is correct.
Wouldn't it lose weight if it was because of the aluminum? I don't understand what you're saying.
I kind of see, because
See the
cracks, the aluminum's going to lose some of the aluminum.
aluminum would lose some of the weight, yes.
But the only weight gain would be from the O2. It can't gain weight from more aluminum.
No, it cannot gain more aluminum. But how, if the coating is on top of the aluminum sheet, then when you read that sentence, don't you think, okay, so I'm getting a new coating on top of it, so whatever mass gain should be from the coating?
No.
No?
Just because it's going to lose mass at the same time as
It's
gaining mass.
all the aluminum you're saying would be, you can't gain
Okay.
any more aluminum. You can only gain more oxygen. You know what I mean?
The aluminum is already there, so you say the coating is aluminum oxide, but the mass difference should be coming from the oxygen?
Exactly.
We can think in that way?
Yeah.
Okay, that makes sense. Good. But I'm good that, I'm glad that I have exposed my confusion with you guys. Thank you for helping to clear that out. Yeah, that makes sense then. Then in that way you can say the mass gain should be only from oxygen, right? Because the aluminum was already there and
It's not going
it's not going
to gain
to gain any aluminum. So even though the coating is aluminum oxide, the mass is only for oxygen. Okay, we could have worded that a little more clearly, I guess, if possible, but then let's do it that way. But oh, don't worry, I'm not going to ask you this tricky worded questions in the exam. I would clearly tell what mass of something, okay, so that you won't be thinking about all this roundabout way to get the correct amount of oxygen or correct amount of aluminum. So what?
You spend all spring break with aluminum oxide.
I know. So let us, I didn't want to show you then that one. Goodness. Let's take a screen and let's work out the problem. I'm not teaching anything new today. We are just going to do probably another example on this one. You don't want to do the example, Cody?
Let us go early.
Oh my! What was the equation, guys? 4 aluminum plus 3 oxygen forming 2L2O3. Okay, and what was the mass of oxygen? 0.9 grams. Okay, so what do we need to do first? Our question was how much is the mass of aluminum we need and how much aluminum oxide will be formed. What was the question? I forgot the question. Oh, that is 6.23. You can read the question from your book. 6.22. Okay. What was it? What was the first question? what mass of oxygen reacted with aluminum? So if this is the mass of oxygen, then we know that. Okay, then read the second question. Okay, what mass of aluminum reacted with oxygen? That is what we are trying to do. So we need the mass of aluminum. We have grams of oxygen. What do we need to do? Grams. Can we do anything with that? No. So what do? Convert that to number of moles using molar mass. Okay. Molar mass of O2. 32. How do I use it? One mole over 32 grams. Okay. So I get the number of moles of oxygen, which is 2.81 into 10 to the power negative 3 moles of oxygen. My question is, or my goal is to calculate mass of aluminum. So now I need, what is it I need next? It is, what did you say? Is the number wrong? Negative 2. What did you guys get? I don't know. I don't have a calculator. You're fine? Okay. So we have the number of moles of oxygen. We need to find out first number of moles of aluminum. How do we do that? Multiply this by the mole ratio between aluminum and oxygen. How will I use it? Which one on the top, which one on the bottom? Oxygen on the bottom, because that's what I have, right? So 3 moles of oxygen, 4 moles of aluminum. Aluminum is what I'm looking for, right? So that should be on the top. So moles of O2 and moles of O2 will go away. How many moles of aluminum you have? Is there a different number? Then I'm taking your number, Cody. So that is the moles of aluminum I have. The question is, what mass of aluminum you need? What is the last step? Converting this to grams using molar mass of aluminum. What is the molar mass of aluminum? I don't know. Look at the periodic table. 26 point something. What is it? 26.98 grams per mole. So what mass of aluminum is required? What? 22?
I'd say
1 point, what was your number? 1.01 into negative 1 grams or 0.101, okay, whichever way you write it, it's fine. So from grams of oxygen, again same steps we are doing, guys. From grams of oxygen we found moles of oxygen. Once you get the moles of oxygen, use the mole ratio. You are looking for aluminum, so that goes on the top, and you have oxygen, so that goes on the bottom. Then finally convert the moles of aluminum to mass of aluminum. What was the second question or third question? How many grams of Al2O3 will be produced? Okay, so the last question is what mass of aluminum oxide is produced? How do we calculate that? Well, now we have two ways. Either you can start with the oxygen, or now you know the mass of aluminum and moles of aluminum. Whichever way you want. Which one is easy? Two and 4 will be easy for the ratio to be used. Then let us pick up aluminum. So we calculated the aluminum's mass 1.01 into 10 to the power negative 1 grams. We can convert that to moles. This is the reverse process of what you did right here. So 1 mole over 26.98 grams. So you should get back the 0.0037 moles of aluminum, right? You don't have to show that. Since you have it right here, you can straight away write what is the number of moles of aluminum you have. So if you have this many moles of aluminum, how many moles of Al2O3 can be formed? What is the mole ratio? 2 moles of Al2O3 per 4 moles of Al. So moles of Al goes away. So how many moles can be formed? This number multiplied by 2 divided by 4, or that number multiplied by 1/2, whatever. Point 00818 moles of Al2O3. Now the mass of Al2O3, what do you need to do? This is what we have. But the question is what mass of Al2O3? Convert moles to mass using molar mass of Al2O3. What is the molar mass of Al2O3? Calculate that, please. We haven't done that one. After doing the, well, what is the molar mass? 101. Oh, I'm writing it in the wrong place. I'm sorry. Erase that. Erase. So 101.96? 96 grams per 1 mole. So what is the mass of Al2O3 can be produced? Okay, let us, grams, yes. Okay, good. I found the small red dot. Oh, let's do it. Let's do it and get done with it. Okay, here is your question. Read carefully. The reaction, you know this reaction. Potassium chlorate decomposing to KCl and oxygen. I have given you the moles of potassium chlorate. Okay? And the question is, how many grams of KCl are formed? You have the moles of KClO3, so, and you have the balanced equation. Oh my. There is not much to do there, guys. If anyone is thinking crazy and doing so many calculations, there is not much to do there. I've given you the number of moles of chlorate. I'll stop at 4 minutes, okay? I know. I heard that. Not to you, I'm talking to Winnie. I said I'll stop at 4 minutes. Still, what is it? I'm supposed to have how many? 19 responses. Yeah, I said that, but okay. If anyone wants to answer, please go ahead. I'm stopping at 4:20. What is there to do, guys? Potassium chlorate and potassium chloride. What is the mole ratio? 2 to 2 or 1 to 1. And I have given you the number of moles of potassium chlorate. So 1 mole of potassium chlorate will give you 1 mole of potassium chloride. 1.24 moles of potassium chlorate will give you how many moles of potassium chloride? The same number, 1.24, right? So you have 1.24 moles of KCl. The question is asking how many grams of KCl. So all you need to do is convert this to grams using molar mass of KCl. And molar mass of KCl is also not a big deal. K and 1 Cl. Adding two numbers. How much time you need for that? That is why I was wondering what is going on here. What are people doing?
First.
What?
Had to figure it out first before I could do
Well, I told that couple of times. I said that number of moles is given to you. Number of moles is given to you. Why would I keep saying that?
because you need a vacation.
Oh, come on, guys. I'm a little bit disappointed here. Anyway, let's finish this. So, what is the molar mass of KCl? 74.5, which is also another number. You have done this so many times in lab, KCl molar mass. So, grams per 1 mole. So, mole goes away, and how many grams you should get? Oh my. I don't know what others did. There was not much to do there. That's why I keep saying there is not much to do. There is only one step to do there. If anyone is doing multiple steps, stop and look again. Okay, so I'm stopping right here, and